In our previous session, we had seen range and endurance. Let us start off with takeoff performance in this session. Total takeoff distance as defined in the Federal Aviation Requirements FAR is the sum of ground roll distance SL0 and the distance measured along the ground to clear a 11-meter height for a jet-powered civil transport or a 15-meter height for all other aeroplanes. The average force in the equation should be set to its instantaneous value at a velocity which is equals to 0.7 VL0. That is, d plus nu r w minus L average is equals to d plus nu r w minus L into 0.7 VL0, where nu r is the coefficient of rolling friction. Nu r varies from 0.02 for a relatively smooth paved surface to 0.10 for grass field. A further simplification can be obtained by assuming that thrust is much larger than either drag or the rolling friction during takeoff. Ignoring d and r compared to thrust, we simply get that the lift-off distance is equals to 1.44 w square divided by g rho infinity SCL max into thrust. Lift-off distance is very sensitive to the weight of the aeroplane, varying directly as w square. If the weight is doubled, the ground roll of the aeroplane is quadrupled. Lift-off distance is dependent on the ambient density rho infinity. This is why on hot summer days when the air density is less than that on cooler days, a given aeroplane requires a longer ground roll to get off the ground. Also, longer lift-off distance are required at airports that are located at high altitude. The lift-off distance can be decreased by increasing the wing area, increasing the CL max, and increasing the thrust T. Now let us look at an example of a CJ1 aircraft. Assume that the runway nu r is equals to 0.02. We have the ground effect factor h by b is equals to 6 by 53.3, which is equals to 0.764. To find the lift-off velocity, the lift-off velocity is equals to 1.2 Vstall, which is equals to 274.76 feet per second. Now we know the velocity equals 0.7 into the lift-off velocity, which is equals to 192.33 feet per second. Average force should be evaluated at velocity of 192.33 feet per second. Hence, to calculate lift, we know the equation. Hence, by substitution, we get 9,712 lb. Now to find the drag, substituting in the equation, we get 520.7 lb. Substituting in the lift-off distance, which is equals to 1.44 w square divided by g rho infinity SCL max T, we get lift-off distance is equals to 3,531.79 feet. I hope you have understood takeoff performance. Let us move on to landing performance in the next session. Thank you.